Something is going on with Mercury, according to the most recent insider information. The James Webb Space Telescope has discovered evidence suggesting that Mercury may have once hosted life forms, challenging our understanding of this enigmatic planet. But that's not all. Mercury may be entirely different from what we thought. It could be hiding secrets that have been right in front of our eyes all along, just waiting to be uncovered. Exploring Mercury has always been considered extremely difficult and dangerous. And for good reason. We now know why. This subtle planet, nestled at the very heart of our solar system, has long been overlooked in discussions about major discoveries within our solar system. However, recent observations made with the James Webb Space Telescope have revealed intriguing clues. Scientists now suspect that Mercury harbors a mystery it has managed to keep hidden until now. Mercury, a rocky planet slightly larger than Pluto and much smaller than Earth or Mars, was once thought to be too hot to support any form of life or vegetation. But then scientists discovered water ice on Mercury, gradually altering our view of the planet. We are now beginning to realize that Mercury may not be the barren, lifeless world we once believed it to be. Perhaps it's time to completely re-evaluate our understanding of the solar system. Mercury isn't as hot as you might expect for a planet so close to the Sun. It's often assumed that Mercury would be the hottest planet in the solar system due to its proximity to the Sun. While it is true that Mercury sits at the top of the list of planets nearest to the Sun, at a distance of only 58 million kilometers, compared to Earth's 150 million kilometers, it's not the hottest. Venus, despite being farther away from the Sun, holds that title due to its dense atmosphere that traps heat. In contrast, Mercury's smaller size means it doesn't have a thick atmosphere to retain heat, resulting in extreme temperature fluctuations. During the day, temperatures on Mercury can soar to 427 degrees Celsius, but at night, they plummet to around -173 degrees Celsius. This stark contrast in temperatures can be attributed to the planet's lack of atmosphere, which prevents heat from being stored or redistributed. In contrast, Venus has a thick, carbon dioxide-rich atmosphere that creates a powerful greenhouse effect, heating the planet to 467 degrees Celsius. While Mercury's temperatures may seem extreme, they actually vary greatly, with some regions remaining cold enough to store water ice. This discovery of water ice is significant, as it raises the possibility that there may be areas on Mercury with milder temperatures, perhaps in permanently shadowed craters or sheltered valleys. These cold regions could potentially offer a stable environment where life, in some form, could exist. This new understanding of Mercury forces us to reconsider the planet and its potential for harboring life. Mercury's surface is also far more complex and varied than once thought. It features large impact craters, including the Caloris Basin, which spans over 1,500 kilometers in diameter. Between these craters are vast plains, likely formed by ancient volcanic activity. Some regions of the planet show signs of contraction, indicating that the planet has cooled over time. Researchers have also identified steep cliffs and towering slopes, called lobate scarps, which are several hundred kilometers long and up to 3 kilometers high. These geological features suggest that Mercury has experienced significant geological changes. For centuries, the planet Mercury was a mystery. Its proximity to the Sun made it difficult to observe, and ancient astronomers had little understanding of it. The Greeks were among the first to record its position in the sky, but it was not until modern telescopes were developed in the 17th century that astronomers began to study Mercury in greater detail. In 1631, French astronomer Pierre Gassendi was the first to document Mercury's transit across the Sun, and in 1771, German astronomer Johann Hermann Schroeder made observations of the planet's rotation. For a long time, scientists believed Mercury was tidally locked to the Sun, meaning it always showed the same face to the Sun, much like the Moon does to Earth. This theory was proven false only in the mid-20th century. In 1859, French astronomer Urbain Le Verrier noticed unusual discrepancies in Mercury's orbit that could not be explained by the gravitational influences of known planets. He proposed the existence of a previously unknown planet between Mercury and the Sun, which he named Vulcan. Despite many years of searches and even some unverified sightings of Vulcan, the planet was never found. It wasn't until 1915, with Albert Einstein's theory of general relativity, that the mystery was solved. Einstein's theory explained that the Sun's gravity bends spacetime, which accounted for the anomalies in Mercury's orbit. This discovery rendered the idea of a planet between Mercury and the Sun unnecessary, though the idea of Vulcan continued to captivate the imaginations of science fiction writers for many years. In 1974, the Mariner 10 spacecraft gave humanity its first close-up images of Mercury, revealing remarkable details of the planet's surface. These images showed vast craters and geological features, providing the first true glimpse of Mercury's nature. Mariner 10 also confirmed that Mercury doesn't have a true atmosphere, but instead a thin exosphere composed of helium and hydrogen. The spacecraft also detected a weak magnetic field, which was surprising because Mercury's small size suggested it might not have one at all. After the Mariner 10 mission, Mercury remained out of the spotlight for several decades. NASA did not send any further missions to the planet, raising some speculation about the reasons behind this. But with new tools like the James Webb Space Telescope, scientists are beginning to re-examine Mercury and its secrets, suggesting that this planet may hold much more than we have ever imagined. Exploring and assembling a mission to Mercury presents unique challenges due to its close proximity to the Sun and the extreme conditions it presents. The planet's gravitational pull, along with the intense heat and radiation from the Sun, requires any spacecraft designed for Mercury to be exceptionally durable. The mission must have a robust structure and a strong propulsion system to avoid it being pulled into the Sun, a costly and catastrophic failure. It wasn't until 2008 that NASA embarked on a serious mission to explore Mercury, with a Messenger spacecraft, or MESSENGER, making groundbreaking contributions to our understanding of the planet. Launched in 2004, MESSENGER successfully entered Mercury's orbit in 2011, and by 2015, it had delivered valuable insights into the planet's geological history. These included compelling evidence of past volcanic activity, expansive plains of lava, and even signs of water ice in the polar craters. The data collected from MESSENGER sparked the interest of scientists, suggesting that Mercury may be far more geologically active than previously thought. Some researchers speculate that Mercury may have originally formed in a different region of the solar system, only to be displaced inward by the gravitational pull of Jupiter. There are even theories that Mercury could have once resided in the habitable zone, where conditions might have supported life. In light of these findings, the James Webb Space Telescope, JWST, is poised to offer new insights into Mercury. Thanks to advancements in our understanding of gas and ice giants like Jupiter and Uranus, scientists are eager to know whether our model of the solar system's history needs to be revised. The JWST is uniquely suited for this task, with its ability to detect tiny changes in light from small objects like Mercury. As Mercury passes in front of the bright Sun, JWST can distinguish the light reflected from the planet's surface from the overwhelming brightness of the Sun. This could provide us with more precise data about Mercury's surface composition. If successful, these observations could reveal whether Mercury is truly an inert, hostile world, or if there are hidden processes and structures that we have previously overlooked. Finding further evidence of water would be a game-changer, suggesting that Mercury is far more complex than we've realized. For too long, the planet has been overshadowed by its larger neighbors, but recent discoveries continue to captivate scientists. One of Mercury's most enduring mysteries lies in its surface, which shows signs of volcanic activity and tectonic movement despite the planet's small size. The Caloris Basin, a massive impact crater over 1,500 kilometers in diameter, stands as a testament to Mercury's violent past. Surrounding this basin are vast plains, possibly formed by volcanic eruptions that reshaped the planet's landscape. These features offer clues about the planet's internal processes and raise questions about its geological history. Mercury's proximity to the Sun also impacts its environment in fascinating ways. Its thin exosphere, composed mostly of helium, hydrogen, and trace gases, cannot shield the planet from temperature extremes. As a result, temperatures on Mercury can reach up to 427 degrees Celsius (800 degrees Fahrenheit) during the day, only to plummet to -173 degrees Celsius (-280 degrees Fahrenheit) at night. Such extreme conditions challenge the survival of life, but recent findings of water ice in permanently shadowed craters at the poles have intrigued researchers. This discovery suggests that, despite its scorching surface, Mercury may harbor water in places where conditions are cold enough to sustain it. The presence of water ice on Mercury is especially surprising given the planet's proximity to the Sun. These cold traps at the poles could hold water ice that has accumulated over time, possibly preserved for billions of years. This not only changes our understanding of Mercury's composition, but also raises the possibility that the planet could one day be a valuable resource for future exploration missions. Mercury's orbital characteristics are also unique. Its rapid orbital speed, traveling at approximately 47 kilometers per second, means it completes a full orbit around the Sun in just 88 Earth days. This fast motion, combined with its slow rotation, creates unusual day-night cycles and extreme solar exposure, further complicating the study of the planet. While Mercury has posed challenges for space agencies, early missions like Mariner 10 in the 1970s and more recent ones, such as Messenger, have expanded our understanding of the planet. These missions have provided detailed images of its surface, mapped its magnetic field, and analyzed its exosphere, enhancing our knowledge of Mercury's geology and atmosphere. Looking ahead, the James Webb Space Telescope promises to revolutionize our understanding of Mercury. With its advanced imaging capabilities, JWST will be able to study the planet's surface composition in unprecedented detail. By observing Mercury as it passes across the Sun, the telescope will analyze the planet's atmosphere and surface features, offering new insights into its geological past and its potential for hosting water or other volatile compounds. The discoveries made by JWST could reshape our understanding of Mercury's formation and development, and by comparing Mercury to other rocky planets in our solar system and beyond, scientists hope to uncover universal principles governing planetary evolution and habitability. In conclusion, Mercury remains an intriguing and mysterious planet. Despite its harsh environment and small size, it continues to surprise scientists with its geological diversity, unique orbital characteristics, and potential to harbor water ice. Future missions, combined with advancements in space observation technology, hold the promise of revealing even more about Mercury's past and its place in the broader context of planetary science.